I would like to take this opportunity to talk about preparation and uses of hydrochloric acid. Dear student, myself Dr. Digna Varghese. Hydrochloric acid. Hydrochloric acid, also called muriatic acid, is a clear, colorless and extremely pungent solution of hydrogen chloride in water. We know hydrogen chloride was first prepared by Glauber by heating sodium chloride with concentrated sulfuric acid. Humphrey Davies showed that the HCl is a compound of chlorine and hydrogen. HCl is an uncolored gas and has a pungent aroma. Hydrochloric acid is the aqueous solution of hydrogen chloride gas. Hydrogen chloride is soluble in water. It liquefies at 189 Kelvin to form a colorless liquid and freezes at 159 Kelvin to form a white solid. Preparation of hydrogen chloride. First method is the direct synthesis. When brine solution undergoes electrolysis, we get pure chlorine, sodium hydroxide and hydrogen gas. Pure chlorine is treated with the hydrogen gas to give HCl gas, and this is an exothermic reaction. Brine solution means a mixture of sodium chloride and water undergoes electrolysis. We will get chlorine directly attached to the hydrogen in the presence of UV light, giving hydrogen chloride gas, and this is an exothermic reaction. Second method is the laboratory synthesis. Small amounts of hydrogen chloride gas for laboratory use can be generated in an HCl generator by dehydrating hydrochloric acid with either sulfuric acid or anhydrous calcium chloride. We know sulfuric acid and calcium chloride, anhydrous calcium chloride, act as dehydrating agent that can remove water from the substance. Alternatively, hydrogen chloride can be generated by the reaction of sulfuric acid with sodium chloride. Sodium chloride and sulfuric acid reacted and forming sodium bisulfate and hydrogen chloride. This reaction occurs at room temperature, but when the temperature raised to 200 degrees Celsius, sodium chloride remains in the generator, which reacted with the sodium hydrogen sulfate to give hydrogen chloride and sodium sulfate, that is known as Glauber's salt. Another method for the preparation of HCl, when treated phosphorus pentachloride with water, giving phosphoryl chloride or phosphorus oxychloride and hydrogen chloride. The issuing HCl gas is passed into distilled water to get hydrochloric acid. Manufacture of hydrochloric acid. Commercial hydrogen chloride is prepared by the direct combination of hydrogen and chlorine that we have already seen, that is obtained as byproducts during the manufacture of sodium hydroxide by the electrolysis of brine. Brine means a mixture of sodium chloride and water, and when treated with the brine solution undergoes electrolysis for the production of sodium hydroxide, we will get chlorine as a byproduct here, and by the combination of chlorine and hydrogen under the presence of UV light, we will get hydrochloric acid. This is an exothermic reaction. Delta H value is minus 185 kilojoule. The strength of the acid produced regulate to about 36%. Here the HCl gases undergoes react with or soluble in water, distilled water, to give hydrochloric acid, and the strength of the acid produced is 36%. Flow diagram for the manufacture of hydrochloric acid. From this diagram we can see there is a silica chamber for the reactants to react, and there is a cold bath region for the production of HCl gas, and this is a collection unit of hydrochloric acid, and the exhaust gases passed through this tube and used water is coming out this tube. Okay, then hydrogen is allowed to burn in dry chlorine in a silica chamber to get hydrogen chloride gas. In this silica chamber, hydrogen burns in chlorine and we get hydrogen chloride gas here. The hydrogen chloride gas formed is cooled by passing through externally cooled pipes and absorbed in water or dilute HCl passed through the connecting pipe. Here the issuing HCl gas is passed through externally cooled pipes, that is the cold water is passing through this and it gives some cooling effect to the highly hot HCl gas, and this cooled HCl gas mixed with the demineralized water or dilute HCl at a controlled rate is passed into the tube in this direction, and these are mixing together and forming hydrochloric acid that is collecting here. The strength of the acid produced here is 36%. The reaction is like this: sodium chloride, water giving chlorine gas, and the chlorine, from this we get the pure chlorine. This chlorine is passed through the silica chamber and hydrogen also come to this chamber, and which burns in hydrogen burns in chlorine giving hydrogen chloride gas. This is passed through externally cooled pipes and absorbed in water or dilute HCl passed through the connecting pipe. By this we get the pure hydrochloric acid and of about 36%. Uses of hydrogen chloride or hydrochloric acid. Hydrochloric acid is used as a laboratory reagent in both qualitative and quantitative analysis that we are using in our daily practicals, that HCl in inorganic qualitative analysis. HCl used in the preparation of chlorine, aqua regia, ammonium chloride and other chlorides. What is aqua regia? Aqua regia is a mixture of concentrated nitric acid and concentrated hydrochloric acid in the ratio 3:1. For cleaning iron sheets during tin plating and galvanization, HCl hydrochloric acid is used for cleaning iron sheets by removing the sulfur dioxide layer during tin plating and galvanization. What is tin plating? Tin plating or tinning, an extremely cost-effective process because tin is a less expensive metal and excellent solderability, superior protection against corrosion. Tin plating can produce a whitish gray color. It can also produce a shiny metallic look when a bit more luster is preferred. The part that receives the tin coating prior to immersion into the plating bath. Tin plating or cleaning removes oil, grease and other surface contaminants like sulfur dioxide, etc. And galvanization is the process of applying protective zinc coating to steel or iron to prevent rusting. Uses of hydrochloric acid. There is another use, ore processing. Ore processing is a 24-hour operation. It consists of the following stages. First one is grinding and sizing. Second one is leaching and adsorption. And third one is the precious metal recovery. During this process, for the recovery of the metal, hydrochloric acid is used. And second one is resin regeneration. Resin regeneration is a process that takes ion exchange resin beads that are exhausted or fully loaded, that can be used in ion exchange chromatography for the separation of certain compounds, and removes the ions that have been picked up during the in-service cycle so the resin can continue to be used. After one use, we can used by this technique, that is resin regeneration technique or process, we can use the used one to the next chromatography or other resin techniques. The basic purpose of the resin regeneration is to restore the exhausted resin, that is fully loaded resin, back to its proper ionic form for the service. Third one is pharmaceutical or in medicine. We know hydrochloric acid is a corrosive, but in some compounds they can be used as medicine or drug. For example, moxifloxacin hydrochloride is an antibiotic prescription medicine approved by the US FDA, that is Food and Drug Administration, for the treatment of certain bacterial infections such as acute worsening of chronic bronchitis, acute sinus infections, community acquired pneumonia, plague, and skin and abdominal infections. There are several other drugs also. Only one example is shown here that can be used as a medicine. Okay. Uses of hydrochloric acid is next use is it is used as a solvent to dissolve noble gases. In laboratory uses, we can use it as a most of the cases it acts as a solvent to dissolve noble gases. Noble gases means highly inert, so it can react with the corrosive hydrochloric acid or concentrated hydrochloric acid, so it acts as a solvent for noble gases. In textile and dyeing industries, textile wet processing is the process that used in any finishing treatment where this process is applied on the textile in form of liquid, which involves some for chemical action on the textile. For example, bleaching, printing, dyeing and printing. That means during these processes, bleaching or printing or dyeing, sometimes we are using the hydrochloric acid. Oil well acidification. Next application of hydrochloric acid is oil well acidification. Oil well acidification involves pumping acid into a well bore or geologic formation that is capable of producing oil and or gas. The purpose is to improve a well's productivity or injectivity. There are three general categories of acid treatments: acid washing, matrix acidizing, fracture acidizing. Acid washing is most commonly performed with hydrochloric acid mixtures to clean out scale, such as calcium carbonate, rust, and other debris restricting flow in the well. Other use of hydrochloric acid is steel pickling. What is steel pickling? Steel pickling refers to the treatment that is used to remove impurities, rust, and scale from the surface of a material. Advantages when we are using hydrochloric acid. Hydrochloric acid is used for steel pickling. Some advantages are there. That is, reduce heating costs since pickling solutions are used at room temperature. More extensive scale removal. By this, less penetration of hydrogen by diffusion, less deposition of iron salts on the pickle's surface. Next application is brine treatment. The main objective of the brine treatment is to remove dissolved sodium ions from the salt in the wastewater. Depending on the origin of certain brine wastewater, additional treatment may be necessary to remove other contaminants such as metals and other ions that give water hardness such as calcium. So HCl can used here for the treatment of brine, that is the wastewater treatment, to remove the metals like calcium, lead or other ions from the water that can cause water hardness. Next application is food processing. It can be used in food industry to process a variety of food products such as corn syrups used in soft drinks, cookies, crackers, ketchup, and cereals. Hydrochloric acid is also used as an acidifier in sauces, vegetable juices, and canned goods to help enhance flavor and reduce spoilage. So it can be in food industry, hydrochloric acid can be used as an acidifier to maintain the pH, and it also used as a flavor enhancer. Okay, in most cases in the canned goods or canned food, and reduce spoilage. Reduce spoilage means it can act as a preservative also. So the applications of hydrochloric acid or the uses of hydrochloric acid, some uses are discussed here. One is steel pickling, other one is brine treatment, and the next one is food processing. And HCl, we know HCl is a good laboratory reagent in both qualitative and quantitative analysis. It can be used in medicine, it can be used in ore processing, it can be used in some tinning or galvanization techniques, or pickling the surface or cleaning the surface, etc. So hydrochloric acid is also used in for the production of chlorine based chemicals or chlorides by the use of hydrochloric acid. It can be act as a good solvent for noble gases. These are some applications of hydrochloric acid. By this we are concluding here. Thank you.